So the first thing I'll say is there's no Game of Thrones reference. People ask me all the time, so I just get it out the way. and we'll see where it goes from there. So game of patterns. I've been interested in patterns for some time. So I like to just introduce kind of like this reasoning process that I went through as I was thinking about it and how organizations work. So every organization or system, we produce patterns, and that's actually kind of how you look at systems in complexity. And so they're optimized to something, whether we acknowledge them or not. Every system is optimized to perform in a certain way. And so the behavior of the organization, it reveals itself in patterns, and it's kind of a theme that I will repeat a few times. And so therefore we can conclude that a system is optimized to produce certain kinds of patterns. So the other reason why patterns are interesting or kind of important are that and you've probably seen this in your work, is that organizations will start throwing different practices in the mix to think that that's going to just solve whatever they're noticing, that it's going to solve problems automatically. So there could be like slow delivery, or maybe the product is kind of expensive for the market. They're trying to like figure out, like we heard about product market fit, those kinds of things, and they're trying different practices, and they think they're going to get solutions. So why do I call this a game of patterns when we talk about systems? The reason why is I was thinking about this idea of gameplay, and in minimal gameplay, what we ask is if you followed the rules. That's the bare minimum. But if you follow rules of any game that you play blindly, or just kind of out of the basics that you might know, are you really playing? Did you really play that game? Did you really perform? So what I'm thinking about, or what I have been thinking about, is that recognizing patterns is the primary game in a complex adaptive system. So when you play games, you have good gameplay and you also have poor gameplay. But what you're doing is you're practicing to perform. So you have to look at performance to really understand what you're doing. And then performance is the actual sign of good gameplay. And so what you need to do is start to develop a sense of taste and practice and understanding what to measure and how to understand that something is well done, to know that you've done well with something. And so when something is not well done and performance is suffering, a deeper look into the patterns and behaviors generated by what you're actually doing and how you're interacting in a system and with others gives you additional insight and awareness. To bring this to life with an example, a few months back now, I guess probably about a year ago, I started playing chess again after having not played for years. My father taught me, and I could move the pieces correctly. I knew how the rook and the knight, the rook and the queen and all the different pieces moved, but it was very clunky. It was a bit awkward, and I would get a checkmate within minutes because I didn't actually know how to play. Knowing how to play chess means something different than just moving the pieces. So my performance was poor, even though I could move those pieces perfectly according to the rules. So that kind of like highlights that idea. So a little bit on systems, now that we've established this idea of gameplay and patterns, it's important to understand systems and their properties to have a deeper conversation about patterns. So in complex adaptive systems, this is like the people system is kind of where I'm going straight to that. You have no ability in the system, only in critical aspects. So, for example, you might be able to understand and ascertain certain behaviors and certain patterns that are present in an organization based on how they do budgeting, how they fund projects, what they incentivize, and you'll see kind of how behaviors that play out and patterns that play out based on that structure. And in a complex adaptive system, anthrocomplexity is a key concept. So when we talk about systems thinking generally, you could think of a hard system is kind of how Peter Checkland referred to it. It's like a feedback control system where you have like integral, derivative, proportional control, you have noise, you have all these things, and that system, that feedback control system, doesn't have any meaning if you look at the parts in isolation. It only has meaning when they're all connected together to provide temperature control or provide servo motor control, that kind of thing. But in an anthrocomplexity, you have parts are less constrained and they adapt and change in certain ways. And that's the human activity system that Peter Checkland described, the hard system versus a soft system. And you have lots of uncertainty and unknowability. But the anthrocomplexity is a key concept here, because beehives and ant hills or ant mounds, they are also complex. Ants respond to constraints, but how they respond doesn't really change over time, except through adapting to the environment. So you can put them in different environments, but they're always going to build an anthill. They don't have self-reflection. But humans, we change the rules of the game. We can change the dynamics. It adds another layer of complexity. It's not just reconfiguration, it's reshaping of the constraints. And so the example I thought of was with football. So humans created these rules over time. We've changed them. There's a FIFA rule book, there's official rule books around for football, but what happens when you're live in the match? The referees interpret what they see, and recently VAR has been added, and so now that adds another element where a VAR referee can challenge what the referee on the field, their call. And so that gives you a deeper meaning and understanding to the game. So that's changing constraints and changing how the game is played. Another aspect of systems that I think is important to understand is this socio-technical systems. So this white paper that I really enjoyed is the Evolution of Socio-Technical Systems by Trist. And he described making an analysis of an organization or a system at 3 levels, which was the primary organization, the whole organization, the primary work system, and the macrosocial phenomena. And the macrosocial phenomena, I'll explain what that means. It's like, it could be like a geographical area. So in his white paper, he was discussing how some experiments and some learning they did and how they changed how minds were run and how the distribution of authority was in the minds. And so what they learned is there was a phenomena in some towns where the minds were located, that because of the friendships and the neighborhoods and social connections, that was an enabler to them being able to work, to how some of the work was able to happen and how some of the connections were made and some of the collaboration that was possible. And you might see that also in a large corporation, like a conglomerate. So you have macrosocial phenomena with bigger bounded groupings in geography and language and company history and culture and languages and all of that. One example of a macrosocial phenomena might be something with Lean, where at one point people thought Americans might not understand how Lean works, because in Japan you had guaranteed employment, lifelong employment, or you could have that. And that created a conditions where you might feel more at ease to pull the and-on cord when there's an error or something wrong. But in other environments where they have a different legal structure, they might not feel at ease and they might bury mistakes because they don't want to be seen close in time and space to a mistake because they could get blamed. So there's low safety and fear of retribution. This is also the space of where things like the Conway's law and the mirroring hypothesis, you might see that at play, is the macrosocial phenomena within a socio-technical system. And so a little bit more on patterns and behaviors. One tool that I've really enjoyed using to describe patterns and behaviors is Westrom's typology of organizational cultures. It's just, I think, gives you some lenses to talk about this. There's probably other ways to describe organizations, but what a couple colleagues and I got together and were working on a kind of like transformation initiative, and one of the things that we thought through was what is the relationship between patterns, behavior, and practices, and that's kind of where we were going with this. And so a system reveals itself in its patterns. It's defined by its behavior. So we use Westrom's typology to think through the top categories of power orientation, rule orientation, performance orientation as a behavior, and then below that constituent patterns that reinforce and continue to support and boost those behaviors. Of course, if you look in different organizations, you may see combinations of these kinds of things, but you may see some that lean towards one or the other. And I think it's kind of interesting if you look at on the left side, With the power orientation, you see like low cooperation, messenger shot, these kinds of things, versus the other side where everyone's centered on performance and the mission and why we're here and what we're trying to do, what we're trying to accomplish together, and they share risks. Messengers are trained to deliver bad news or deliver information, that novelties enacted, those kinds of things. You can just see the contrast there. And kind of that's how we use this tool to communicate this idea of behaviors and patterns in the system. And to take this a little bit further, we considered this outcome statement. It's this actual outcome statement that an organization that I worked with had for themselves, which was to enable a generative culture where technology, products, and people and the operating system continuously evolve in the marketplace. In here we see that the behavior, if we took Westrom's typology, we could make an example. We kind of expanded what that might look like and what we might see in organizations. Is the behavior of being rule-oriented will have patterns of monitoring and controlling often. And so what kinds of practices might connect with monitoring and controlling patterns? You might have traditional project management is a lot about monitoring and even in like the PM, in the PMBOK itself. You have a focus on collecting data. You might have various siloed information processing and waterfall design and designing for security, which is kind of where you kind of over adjust to make things safe, but you kind of cover over errors and surfacing where there's vulnerabilities, which actually could make things safe. So this behavior as manifested in these patterns is likely antithetical to this outcome, and that's what makes that, therefore, an anti-pattern. So patterns are actually just patterns until they aren't. So if you reconsider this outcome statement and take it from the lens of Westrom's typology of a performance-oriented, performance-behaving organization where they have more guiding and enabling patterns at play, what might be some of the practices that you see enacted or leveraged or used. You see more adaptive ways of working, focus on insights, information that supports good decision-making, automation, raising the level of abstraction, focusing on value delivery, designing for trust. So the insight focus enables solid decision-making to guide the organization towards good performance, which is that good gameplay. Some of the other things that you might see in the performance-oriented organization is an understanding of these practices, which from like social practice is the integration of meaning and purpose and skill and tech and material. And the patterns that you get in the organization, they emerge from how we use the technology and how we structure the organization. So again, what to highlight here is the relationship between your goal and the materialized patterns. There's a connection between behavior, patterns, and practices. So I wanted to focus on agility as an example, as we're here to talk about agile, sort of. And so, we talked about what good performance is. It's not just following rules. It means something else. It means something deeper. And so, again, I really love white papers. So there's another white paper. It was called Agile-Based Patterns in the Agile Canon. And I use this with my teammates, and in this particular organization we're working with, well, I'll show a case study in a few moments, where there was 5 base patterns of agility. And his point was that the practices didn't matter. But if you think around pattern language and this idea of these like characteristics and things that you would see consistently in organizations, and it would show up in different ways, but the practices would reinforce and create and help these patterns emerge, these are the 5. So measure economic progress that is being insights focused, kind of how I mentioned before, versus data collection focus, from data rich and being data rich but information poor. A lot of organizations will measure everything, report on everything, thought to be interesting to executives, but there's little insight that actually supports decision making. So in this case, we often use the Odom framework by Larry Mascheroni. It's a good tool for developing metrics that are balanced and that actually support decisions. Proactively experimenting to improve, that's evolutionary, could be revolutionary experiments of different sizes, as the white paper calls out. Limiting work in process, we've heard that. limiting work in progress. It's that work that started but not finished. It's mentally exhausting. It causes us to mistake activity for accomplishment, and it hides process problems and waste that are lurking in the system. And then embracing collective responsibility. This is an interesting one that we worked with different ideas about what it means to learn and what it means to practice together and what it means to develop these patterns. And there's one concept called interpredictability, and that's the increase of peer-to-peer working together. It's co-working. It's not asynchronous work, like I do something and hand it off to you and let's see what you do with it, but we actually co-create, because that's that social practice where tacit knowledge becomes exposed and shared in different ways and integrated in different ways. And it allows us to build and create new things. We know Deming was famous for saying that quality was everyone's responsibility. So that's another way of saying collective responsibility. And in an Agile world, we hear about collective code ownership. We hear about, or that the team is the base unit of value delivery. And it's this world of the embracing collective responsibility that I also connect to this concept of skills liquidity. So just like when you have financial liquidity, you can move your money around. Imagine if you have skills liquidity in a large system, and you can kind of de-Brent. When you have, Brent from the Phoenix Project that had his hand on the keyboard, couldn't take them off, and he was like a single point of failure. De-Brenting, where you share knowledge, you share skills, you kind of like learn how to build together. And then the last was solving systemic problems, which is moving beyond the actor boundary. So if you go back to that image of the socio-technical system, it's about hunting for systemic problems, hunting for these patterns, anti-patterns. It's for hunting where things are out of balance in the socio-technical system. So where Lean might say to just eliminate waste everywhere, and you have something maybe like a theory of constraint, you can kind of mix that in to say, well, let's hunt for waste. Where are things out of balance? What's actually happening in the system? What do we understand? What patterns what are our patterns? What are the anti-patterns? What's the outcome we're trying to achieve? And kind of actually stepping back and thinking about things, thinking about our purpose in the organization. So I have an example I'd like to share of a team I worked with. I call them the FAN team. These are how they exhibited patterns, and it's in a cyber-physical environment, so it's kind of a low cyber application, what they did with not much software. And the reason why this became really important in this particular project was because in this large organization, they had lots of software development, lots of hardware development, and kind of everything in between. And they were trying to come in with safe and say, well, safe is going to be the answer. Let's roll out the unbox safe, and that's going to help us build and develop products more effectively. And so they had a research and development department, and they had other big programs that they were working on. And this is, excuse me, with the research and development department. So what happened was some research scientists, a research scientist did some initial calculations and modeling around applying a fan blade in a new material. And they needed funding to do this, and so they assembled a year-long Gantt chart, a year-long plan for how they were going to do this. All the usual tasks, dependencies, and in fact they used the V model of engineering, and this is for research and development, about how long each phase would take. And there was a leader who was sponsoring this effort, and he said, I don't even want to present this for funding, because this is going to set expectations about what this is. And not only are we trying to solve this problem, but we're trying to show that we can solve it in a more effective way. So how could we present a different plan? Because this looks like business as usual. And so this was where they were questioning, well, is safe the way to go? And how can we actually do this? They had a group of engineers and rocket scientists that they picked that could be great to work on this program. So they wanted to figure out how to do it. So I got the team together into a room. It couldn't have been any simpler of a workshop, really. And so instead of this Gantt chart and this rigid plan, we created a presentation describing how they performed the experiments. And it started with me asking a question. I said, well, just putting everything aside, what are you trying to do? Why are you here? And they said, well, we have done these calculations, and we think an engine fan blade will work in this material. So I said, well, how would you do that? And I said, well, we can make it over here at this facility. We've identified a facility that they can produce it. They have the ability to do that. And we have a lab. We can throw the thing in the lab and put it on a rotor and like blast it at power and see, does it fly away, does it crack, does it melt, like what happens? I said, okay, well, just write that down. So literally just write that down. We're going to manufacture it here. Here's who the team might be. Here's what we want to test. Here's how we're going to test it. And that's step number one. So if that goes well, what would you do next? I said, oh, well, the next thing you do, we put a housing on it. That's experiment number two. Like you see on an aircraft. Okay, great. So if that doesn't fail, when you put the housing on it to mimic a typical engine fan housing, then what happens? And they said that would be the test. I said, okay, write that one down. And they said, okay, well, what's the next test? Is that it? Was it one more test? They said we need to change a couple of other parameters. We need to like tool the blades, maybe get them to 100% efficiency. I said, okay, well then write that one down. I said, would that be enough? They said, yeah, well, if we could get to experiment 3, we've proven that we could actually put this on an aircraft. And so that's what they did. They wrote this down, and they put that in their plan instead of the Gantt chart, and they received funding. Another thing that was really interesting here is a kind of a complexity topic is this idea of preserving optionality, is that they prioritizing items based on their expiry, and they delayed commitment to the last responsible moment on that blade refinement. So that was one of the things they would typically worry about up front. Before they do the refinement and tooling of those engine fan blades, they actually have somewhere between 90 and 100% efficiency, which is good enough to test the material's function, its basic function, and then they could move on later when it was necessary to that refinement of the mechanism. So, like I said, they received funding, and then once they got the money to do this, I say, well, so where do we start? So. I basically took those base patterns that I called out before, and I said, and then kind of create a picture of like how this worked, how this came together, and how this team was able to accomplish this. So, the first thing they did was they said they couldn't put anything on the wall. This is a top secret program. It's a red program. No one can see this. I said, well, so you can't have a team room. And no, we can't have a team room, because that would be different than how they work, because they would, the different engineers and scientists would do their part and kind of hand it off. They wouldn't really sit together and noodle on the problem together. So I said, okay, let's think about this for a second. And then one person chimed in and said, well, can we just use Excel? I said, sure, okay, let's try Excel. You've got Excel, you can't put it on the wall, you don't have any other digital team board. Let's just start with that. But let's design a workflow together. So I taught them some basic workflow concepts, or like Kanban, and I gave them some heuristics and rules of thumb to use, and then they got started. And then they came back a couple of weeks later to help them some more and unblock them, and we discussed their challenges. And by that point, they had already added a color coding system to show who was working on what, when things were blocked. And the way they controlled the work is they would do a weekly a daily 3 times a week, like stand-up check-in type thing. And they had one person, and his role was to update the boards. The first thing they would say, where are we at right now? Okay, let's move. Okay, that's where we're at right now. Now, what are we gonna do next? What's our plan? How are we gonna do this? The other thing is I gave them one other rule of thumb. I says, you usually do handoffs. Anything that you see there's an opportunity where you can collapse the work and work together and do it simultaneously and solve problems together versus just handing off from different systems or different tools. Try to do that. And so they used that tool and found a way to do that as well and pair up rather than just kind of like sending things on. The other thing, so that was part of actually the embracing collective responsibility, limiting work in progress. That was part of this working cross-functionally, which I just got a little ahead of myself. So for the work that they would hand off between roles, they would do it collectively. So kind of like pairing, kind of like mobbing, that kind of thing. And these were rocket scientists and systems and mechanical engineers and that kind of thing, and it still worked for them. This is not a picture of the facility. Like I said, it was top secret in the red program, so I got a Rolls Royce picture. So one of those things when I tell you I have to kill you thing, so this is not it, but it would look something kind of like this, a test lab where they this is the scale, like a large aircraft engine fan blade, that kind of thing. So solving systemic problems, that was one of the other base patterns that I mentioned. So what they learned is they were getting blocked when they had to get into this lab to do work, to test one of their iterations of the fan blades. What they discovered that there was one person in this entire 400 or 500 person facility that was responsible for the lab setup. He was the expert. And he was booked for weeks and weeks and weeks and weeks. So what the team did is they sent one of their teammates along to pair up with this person, the lab setup person, and document everything he did. And he reviewed it. And then they walked through and they did the lab setup with him. And they published that. And now other people could safely set up the lab and not be blocked by this person that had other things to do as well. And they removed this bottleneck for the future. So that's like a small example of getting together and solving these problems together. The other thing that they did in collaboration with leadership is they removed those review gates. So they had standard work had sort of seeped into the research and development department, and they had this stage gate V model of development. And so they rid themselves of that by doing live demos in the lab at the end or frequently throughout one of those experiment cycles with people who were interested in seeing how this was going and could, provide advice or just, out of interest, see what was going on. So when something was in the way of the team, leaders would unblock them, but they would give no other direction than the strategic vision, which was to demonstrate that they could build this fan blade out of this new material. And they kind of use these principles of decentralization of some of the decision-making and control, these small batches and experiments, which favored resiliency and responsiveness. Like I said, didn't have review gates. They had demos, and one of the things that was really, really great by this is that they caught a major design flaw. So they were able to correct this design flaw very early, and because they were working so differently, the lead rocket scientist of the project declared that it was caught months and months sooner than it otherwise would have, because he had seen something similar happen before. And he connected how they had shifted the way that they typically work to the ability to surface and learn, learning farther upstream. Surface issues and move learning farther upstream. So what were these observed patterns? What emerged? How did this whole thing work? Well, in anthro-complexity, when the team is used to working in a certain way with these typical patterns anti-patterns in this case to the outcome that they wanted, we couldn't assume that they would just go into the room and figure it out. There's no reason to assume that they get anywhere. So in this case, the few heuristics and rules of thumb that I gave them and a little bit of teaching how to Kanban and kind of backing away and coming back and helping unblock them and them experiencing this new way of doing things set the conditions to make them more successful, more likely to be successful. And it was basically constraints management by modulating the constraints and not telling people what to do. So as they used and further honed these and developed these ways of working, we looked back and we stepped back and we said, are the patterns that we expect to playing out? Can we change the constraints in any other ways to get the patterns that we want to emerge? And we kind of worked that way. And it's not just an ethical statement, but the minimum amount of process actually produces better outcomes for everyone. So the minimum constraints to get started, it's better to start under-constrained. Under-constrained in this case would mean we would incrementally elaborate, because whenever they would intervene, a new problem whenever they would intervene or try something new or take a suggestion on, a new problem or a new a new awareness would happen. They had to grapple with that. And so as those new things happened, we have excess work in process, or we're stuck in the lab, or the work item size, or we have to coordinate what's blocked, or whatever it was that they needed to do, they came to those realizations, and they were the ones that were able to do that, and they had information that was timely that they were able to process when they could process it because of those new revelations and because of that kind of mechanism of starting to work in a new way. And that's when you get learned helplessness, is when teams try solutions to things that they can't actually observe or yet perceive. And so that's kind of how this worked and how this change emerged. And I did a Wardley map of this as I was thinking about how this might actually work, but very, very, very quickly, is that the map is meant to explain value chains and the current state for an applicable market. So I assumed that this organization, or any organization, is an applicable market. And so from an intervention standpoint, we need to diminish on the right the value chain that's functioning, that is focusing on design artifacts and Gantt charts. And so one way you could do that is if we're talking about certainty and ubiquity in the organization, there are certain practices that are standard and assumed and just done, versus things that are in genesis, which are like those new ideas and new practices, where something's new and never been tried, and maybe it's floundering. And so the example I gave in that rule-oriented behavior, that depended on monitoring patterns, depending on data collection focus and practices. So if you have perfect authority to outlaw the spreadsheet and data in the presentations, maybe you outlaw that for the fan team, for example, and that would erode support for that data collection focus. And the outlaw could be framed as like a constraint or a challenge in the given context for the team. And so when they got heuristics and simple rules that they could follow and that they could grasp, but they were trying and demoing in the lab, that's the intervention. And that opens the opportunity space now for those demos to come in and then begin to mature towards where the Gantt charts used to be. And at some point, one of the chief rocket scientists said that, I remember how we used to work. We would get into a building, we'd just start building until we got it right. We would just start building together. But somewhere along the way, this red tape came in and we slowed down. And that's that standard work that I mentioned that had made it into R&D. So imagine research and development so focused on schedule and scope, it seems a bit mad when the whole point was to answer questions about design problems and possibilities as effectively as possible. So the conclusions that I thought about were addiction to practices and this idea of bounded applicability. So beware of addiction to practices as a silver bullet, or solutions to problems without knowing if they're meant for your context. Learn to build skills about what to measure, what to notice, centering on the desired outcome, and notice that there's a relationship between your goal and those materialized patterns, and there's a sense of taste and practice that develops over time. Remember, the fan team got started and they progressively noticed and progressively understood how to control their work, how to make modifications that got rid of bottlenecks, how to catch quality issues sooner, removing the stage gate inspections, focusing on less focus on timelines over focusing on problem solving for the fan blade. Develop the capability for teams not to sense just what domains their work falls in, but also the capability to operate and understand which practices and guiding principles will actually be useful to them. And learning how to play well. That's the other thing I thought of, is that, again, it's that performance that's a sign of good play, needing to know what to notice and what to measure that something's well done. So if you try Scrum or XP or any other practice, it doesn't really matter. Leveraging them as constraints to observe and notice what patterns emerge in the context. What emerges as you use them is something unique to your organization. And part of doing good work is not just the code you write or building the engine fan blades, but also the work on the system that enables you to develop value. And lastly is that awareness of anthrocomplexity in a socio-technical system. I think it changes expectations. So we can't always expect each other to have their answers and consistently get results, especially if we haven't created the conditions for learning. So through an understanding of patterns and moving constraints, changing the opportunity space, opening the possibility space, I cannot overemphasize really the importance of creating the conditions for learning. So a brief anecdote, a team that I worked with many years ago, they had a developer, the tech lead was on the verge of firing a young developer. And after the team got training in XP practices, they decided to try pairing and rotating pairs. And the young developer began to flourish. And they thought he was a whole new person. But it wasn't the case. It was the same person. But this collaboration format and the learning format is actually what allowed him to contribute and learn and feel a part of the team, and rather than going to the individual. So constraints have been modulated that he could learn through doing. And so I think this actually helps organizations to become better and better places for all of us to do good work together. That's it.